new year, we're about to make discoveries of an entirely new world. Good afternoon. We're live from the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. I'm Mike Buckley from the APL Communications and Public Affairs Office. And NASA's New Horizons spacecraft, in just about 10 hours, will zoom past a Kuiper Belt object nicknamed Ultima Thule, the farthest exploration of worlds in history. So we're here today to update you on the status
Wait
of
a
the
second.
spacecraft.
Did he just call it Ultimate Thule? Thule? I've been calling it Ultima Thule. What the hell?
We have the panel here. We're going to take questions from the media assembled here at APL, and we're also going to take some questions over the phone. In fact, I'm going to get right into the panel
How's
and
the volume
introduce
now?
them, who are going to bring us up to speed on the mission. First, we have Alan Stern, Principal Investigator, Southwest Research Institute in Boulder, Colorado. Helene Winters, New Horizons Project Manager from the Johns Hopkins Applied Physics Laboratory. Fred Pelletier, the Navigation Team Lead from Kinetics Incorporated. And John Spencer, New Horizons Deputy Project Scientist from Southwest Research Institute. Dr. Stern.
Good afternoon. This evening, the United States, through NASA and the New Horizons project, will make history. The farthest exploration of worlds ever attempted, 4 billion miles from home. I'm here to tell you that the spacecraft is on course, it's healthy, it's conducting observations as we speak, and it's going to arrive on time at 33 minutes past midnight, 33 minutes into the new year, Eastern Time. New Horizons launched in 2006 on a journey to the Kuiper Belt, the third zone of our solar system. Traveling at a speed of over about 10 miles per second, 24/7, 52 weeks a year, it has crossed this 4 billion mile ocean of space to the very frontier of our solar system. You see here in this image behind me the trajectory of our flight out into that disk of material we call the Kuiper Belt. The Kuiper Belt is a scientific wonderland that can teach us about the origin of our solar system and the planets in it. The first objective of the New Horizons mission was to explore Pluto and its system of moons, and we did that spectacularly in the summer of 2015. And after revolutionizing our knowledge, not just about Pluto and its moons, but also about dwarf planets in general, we went on, now on an extended mission, where we're going out into the Kuiper Belt almost twice as far as Pluto, ultimately. We've traveled another billion miles in that time since the summer of 2015 to intercept this small body we call Ultima Thule, this Kuiper Belt object. And it is history-making, what we're doing. As we've said a couple of times, this is the most distant object ever explored. But it is, in addition, because of the cold temperatures out there, the most primitive object ever explored, and therefore probably the best time capsule we've ever had for understanding the birth of our solar system and the planets in it. Because the target is very small, the flyby is going to be very brief. The lead up to Pluto was more than 10 weeks long. We were only able to resolve Ultima for the first time from about 1 million miles away yesterday in an image that John Spencer will be showing you. This is also a much more challenging flyby than the flyby of Pluto, and it's taking place at an auspicious time on New Year's Eve and New Year's Day 2019. The reasons that this flyby is tougher are many. We're farther from the Earth, and so the communications times are much longer. We're farther from the sun, and so the lighting levels are lower, making it more difficult for our cameras and spectrometers to operate. In addition to that, we don't really know the environment around Ultima as well as we did know the environment around Pluto. And so we're taking some risks. Also, its orbit is not perfectly known, and making the intercept is tough. And finally, because the spacecraft is older, its power generator that's on board produces less wattage, so we have to manage our power much more carefully. All of these things add up to a much tougher, much more challenging flyby than what we had to do at Pluto, and I can't promise you success. We are straining at the capabilities of this spacecraft, and by tomorrow we'll know how we did, so stay tuned. There are no second chances for New Horizons. And I want to just close by saying, you know, the reason that New Horizons has been successful in its flight so far is because of the New Horizons team, an amazingly talented team of men and women, engineers, scientists, technicians, flight controllers, each of whom has been dedicated to this project and really poured their careers and their life, for that matter, into it. And there are many stories of individual contributions that made this project possible. There are many teams. We are a team of teams. But I want to point out one particular challenge and one particular person today, because we would not be here if it were not for him. You know, New Horizons is the first spacecraft to launch on a mission when it didn't have a target. We only discovered Ultima Thule in 2014 using the Hubble Space Telescope. And the man who's responsible for that discovery is our co-investigator, Dr. Mark Bowie of the Southwest Research Institute. And not only did Mark discover Ultima, he also made it possible for us to intercept it by developing state-of-the-art techniques to perfect our knowledge of its orbit well enough to hunt it down in the darkness of the Kuiper.
Yeah, they had strong opinions on New Horizons and Ultima Thule and his pronunciations.
Thank you, Mark. Okay, and with that, I'm going to turn it over to our project manager, Helene Winters.
Thank you, Alan. Okay, I'll update you on our flyby plans. Okay, our payload is comprised of 7 science instruments. 3 of them are cameras, and we have the REX instrument, which uses...
All right. Seriously, I want to appreciate the names of the instruments on this for a second. Ralph, Alex, and Rex. That's amazing.
So the LORRI camera is the first device, the first instrument that we were able to use to see Ultima Thule. It's our long distance and ranging camera. We were first able to see Ultima Thule with it on August 16th of this year. And since then, we've been taking images, and it's gotten closer and closer, and we've been able to image it better and better. Initially,
is that where that's from?
Times and do what we call co-adding, take multiple pictures and layer them over each other so to see it in the sky. At this point, we don't need to do that. We don't need to co-add to see it. We can see it with the LORRI camera by itself. If you look at this crowded star field, it would be very hard to detect Ultima Thule in it. And Mark Bowie had used a technique similar to what Clyde Tombaugh had used to find Ultima, taking pictures, multiple pictures over a period of time and seeing it move in the night sky. Now here is where it actually is, where Ultima Thule actually is in this sky, in the region of Sagittarius. At the top part of the oval that you see, the ellipse that you see, you'll see it appear when I show you this film clip. This is layered multiple images taken over the last month. And you can see it growing out of the center.
Oh, wow.
So those are the pictures we've taken, like I said, over the last month with the LORRI camera. And now we're able to see it just now with the Ralph camera as well. So here's our timeline of flyby activities. We have, you can see in August where we first were able to image Ultima Thule with LORRI. We've been taking what we call optical navigation images, or OpNavs, with LORRI since then. And still, we're taking them OpNavs daily. To better, we were taking them to, at that point, to better understand its position. And then we did a series of maneuvers, trajectory correction maneuvers, to adjust our spacecraft's trajectory to better, more precisely target that close flyby at 3,500 kilometers or 2,200 miles from the center of Ultima Thule. As we got a little closer in the November time frame, we also made hazard observations.
Hey!
Pictures to look very closely for any potential hazards, perhaps moons or rings that might obstruct our path along the trajectory. We did not detect any, so we were able to fly our optimal trajectory to 3,500 kilometers. Had we found any obstructions, we could have flown by at 10,000 kilometers. We would have had a divert maneuver to fly to that farther distance. But we were able to fly by at the optimal distance for the science folks. And you can see at the vertical line is where we have our closest approach. And then we're downloading data already, downlinking data from the spacecraft. And we'll continue to downlink data. We'll get just a bit before we go into solar conjunction from the 4th through the 9th of January, where the Earth will be on the far side of the sun from the spacecraft. So that would interrupt our communications with the spacecraft. So during that time, we won't be able to get much data down. And then we'll resume our downlink beyond that, and it'll continue for a period of about 20 months. Okay, here we have an expansion of the inner part of that timeline. We recently were able to make timing updates based on those OpNavs as Ultima Thule gets closer and closer. We were able to tweak the information that we store on board the spacecraft about the location of our target body. So we were able to adjust the timing by 2 seconds to better image it, and adjust our pointing so our images more accurately capture as centered as we can be on Ultima Thule. And then you can see closest approach at the circled green diamond. So the blue diamonds before closest approach on the timeline are what we call our fail-safe images, where we've taken images on the approach in case anything should happen at flyby to the spacecraft where we wouldn't be able to get the data down. So we have those on the ground, and we'll be showing those. Basically, the fail-safe image will show, the second fail-safe image will show at our press conference tomorrow, and on the 1st at 11:30, and then each day for the next couple days, then we'll have press conferences at 2 to show the images that we've collected from the day before. And then beyond closest approach, you see where we have essentially our quick look images, our first opportunity to look at the flyby images. They won't be at full resolution that we'll see, but John will talk to you more about that, the images that we'll see later as we get closer and are able to downlink those.
Okay, thanks. Navigation is about driving the bus to the destination within the requirement set forth by the scientist. You see on this image a close-up view or our flyby trajectory at closest approach, where we're going to fly due north of Ultima Thule, about 2,200 miles away. And the goal of the navigation team is to determine the relative positioning between the spacecraft and...
I mean, even if it's not the satellite bus, I still find the term amusing. We're gonna drive a bus.
Get the timing within 80 seconds or so. So considering that we are 1 billion miles beyond Pluto, this is quite an achievement and a challenge for us. And as my colleagues mentioned, we are using the LORRI imager to get our relative positioning. But the first thing we need to really capture or understand is the position of our spacecraft in the solar system. So we achieve this by using the Deep Space Network, which is a series of antennae that NASA has that are strategically positioned around the globe in California, Spain, and Australia, that are designed to basically see the NASA spacecraft all the time. And then we are basically using these antennas not only for uplinking comments to the spacecraft or downlinking images, but also to get our velocity and ranging information for the spacecraft. Then we need to worry about our targets.
So Hanny asked, what are we expecting to learn from this flyby? Would this explain things about Pluto? Probably. As far as we know, this is the most primitive object from the solar system that we've ever flown by. So yeah, I expect that they're going to want data from the early bits of the solar system from that.
Starting in August up until very recently with the Hubble imagery, that we can really get the positioning of Ultima.
Fenring says, assuming all goes well with the instruments, I wonder how much motion blur is going to affect the image quality. I don't know. I hope it's not a whole lot. I think we can correct for some of it, but not a whole lot of it.
And the missing piece, the final piece, was to acquire the images up to the 30th of December to basically get us the final relative positioning so we could uplink that, the final pointing update to the onboard the spacecraft. And we did that. We designed this solution 2 nights ago. I wanted to go back to the optical imagery that we did, that Aline presented, and maybe give a little more detail on the challenges.
Yeah, I really still love this image. It's pretty amazing.
Imagery that we are working with, and there's a lot of stars in there. The resolution is not the best, so it's a real challenge to really pick out where Ultima is. So what we do is we do a series of processing. One piece is co-adding, like Aline mentioned, and we also are refining the resolution on the imagery, since we have many images to work with. And lastly, we are subtracting the stars to clean it up, and that's the image you see, or the video you see on the right. So I want to end up with a global view of our trajectory work since launch, maybe focusing after the Pluto flyby in 2015. We did a series of 6 course correction maneuvers. The first one was 100 days after Pluto, where the maneuver was fairly large, and we had to break it up into 4 pieces to make sure that the spacecraft could execute it. And then the last one, like I said, was on December 14. And I compared this to essentially trying to hit a requirement size of the size of a golf ball if you were to start from the West Coast and try to hit your bullseye on the East Coast. So with that, I think everybody's excited to try to see some science imagery. I'll turn it over to.
Yes, so I'm going to tell you a little bit about what we hope to accomplish with this flyby. We have a series of science objectives. One of the prime ones is to map the geology of Ultima, whatever craters it might have on its surface, whatever fractures, other topography, anything that will give us clues as to how its surface was.
I think the problem is the speed of the craft and how long it takes for data to get back to us. And it sounds like it's going to take months to download all of the data. I imagine that they're going to prioritize a few bits.
Know why Ultima and objects like it in the Kuiper Belt, there are hundreds of thousands of objects we think like Ultima out there, tend to be dark and red. We think they're mostly made of ice, but their surfaces don't look icy, they look dark and red. So we're hoping to delve into that mystery.
Hey, welcome,
we're also looking
Moron.
for satellites and rings.
I'm just going to call you Mo.
Moons that are very small, less than a couple of 100 feet across. We haven't found any moons yet, and this image shows a view from a couple of weeks ago where we were looking in the area around Ultima to see if there was anything hazardous. And we didn't see any hazards, we didn't see any moons, any rings, but we can look with much more sensitivity now because we're so much closer, and who knows what we might find. And after we fly past, we'll be looking back towards the sun and looking for...
Happy New Year. I'm not talking a whole lot because they have a lot of good info, and I want you guys to be able to hear it.
We know of one other Kuiper Belt object and another object originally from the Kuiper Belt that do have rings. And so anything is possible out there in this very unknown region. We're also looking for any gas or dust that's coming off Ultima. We don't expect to see this at all, but comets do show this kind of behavior, and this is a spectacular image of the comet CG taken by the Rosetta spacecraft, showing these spectacular plumes of dust and gas streaming off from it as it's heated by the sun. Because Ultima has been in the same orbit for 4 billion years, any gas that would have evaporated has probably evaporated long ago. But this is unknown exploration. Anything is possible. And so we're doing our best to look for even these rather surprising and unusual possibilities with the observations we're taking. So we're making ultraviolet instruments, and we're taking images, backlit images, to look for this kind of thing. We are starting to learn about the shape of it, and I'll show you in a minute our first clues on that. But we don't know very much up to this point. We have the shadow of Ultima as seen from its passing in front of a star in a effort that was actually led by Mark Bowie again, to get some idea of its shape. And we see those two red circles give some approximation to how we might explain the shadow that we saw from those observations. And that might mean it's two objects that are orbiting around each other. And as we've got closer, we haven't seen evidence for that. But we still have to get the really close-up images to be sure. Or it could be a single object that is elongated. It could be a couple of objects that are stuck together and are resting on each other, kind of like the artwork you've been seeing here. And so we'll find out soon enough, and I'll show you some clues already that we have. We don't know if the surface is going to be covered in craters, which we might expect, but there's some recent ideas that, no, we may not actually see craters here because things don't run into each other very often in the Kuiper Belt. We might see evidence, like again on Comet CG in the middle there, of sublimation where gas and dust has left the surface and left holes behind. Or we might see something really crazy. This is, on the right is a picture of Saturn's moon Helene, no relation to our project manager, which has this crazy eroded surface. And so anything is possible out there when you're exploring.
Hanny asks, how do two objects find each other in such a sparse region in space? Chance? Probability? Starstrider probably knows the answer to that better than I do.
Our first images that show any kind of detail we got down last night, I'm going to show you those in a moment, but don't get too excited. Then tomorrow we'll be showing images that show more pixels, about 6 pixels across, will give us some idea of the shape. And then if everything goes smoothly on January the 2nd and the 3rd, we will have more detailed images where we'll begin to see features on the surface. What you're seeing here are simulations.
These are simulated images, and related to this, Hoot My Root asked, did we get to see the two photos that have been taken on approach? Yeah, they showed some of the photos that they've taken and altered a little bit. It doesn't really look like a lot unless you're working with this data. It just looks like a blurry pixel.
Which is what came down last night and has already got us very intrigued. And here we go. So the image on the left is...
There we go. But I called it. It looks like a blurry pixel.
But you can see just from that blob that it's an elongated blob. It's not round. And so we're already seeing that there's some interesting shape to this thing. And this is somewhat consistent with that shadow that we saw from the observations from the Earth. So that's not too surprising. But now we're...
Pixel art indeed. Definitely pixel art indeed. I like the raw versus the sharpened.
Indeed, it's quite an elongated object, maybe twice as long in one direction as it is in the other direction. So this is just our first taste. We're going to learn more very, very soon, and we just can't wait. So thank you.
Disillusion says in response to the image, enhance.
Thank you guys for that overview, too. I never saw a team get so much out of a dot, right? We've been doing for so long. Before we move on to the questions, though, Alan, I believe you had something else to share.
Yeah, I do. Thank you, Mike. As you might imagine, I'm getting a little extra email this week. Overnight last night, I received one email that I want to read in its entirety. It's from Dr. Thomas Zurbuchen, my colleague and friend who directs NASA's entire science enterprise and runs the Science Mission Directorate. So let me read that to you. It's 3 paragraphs. It said, Alan, as you know, we are on government shutdown and I am unable to contribute to this historic event like I intended to. I will be sure to be there tonight, though, with my family, and here's why. I think that it is fitting that this flyby of Ultima Thule is at the interface of the 60th anniversary of Explorer 1 in 2018 and the 50th anniversary of Apollo 11 in 2019. To me, this milestone of New Horizons is full of everything NASA and NASA science is all about. It is about boundless aspiration and hope that are the inception of exploration. It is about innovation and persistence and perseverance to actually create the success by an amazing team that transcends what is reasonably expected or even what seems initially possible. And then it is about surprise and transformative learning that has been at the heart of NASA and NASA science and exploration during the past 60 years. The Ultima Thule flyby has all of these. For all of those reasons, I wish you and your team the best of luck. We at NASA Science are incredibly proud of you and your team, both the science team and the engineering team, and we can't wait for the surprises that will be uncovered during the next hours and days. Go New Horizons, go exploration forever. Thank you. Thank you, Thomas.
Aw, that was really sweet. Like, seriously, really sweet.
I just hope that Thomas doesn't mind me reading his email to the world.
Thanks. So with that, we will go to questions for the media assembled here. I know a lot of people are following online too. So if you are following along with this mission on social media, we are on nasa.gov and we are also on pluto.jhuapl.edu with the hashtags Ultima Thule, Ultima Flyby, and Ask New Horizons. We'll take questions first here in the audience. I know if the media, if you have a question, we have people on the aisles.
So, as a reminder, if you're to ask questions, please at me, and either myself or Star Strider will, or somebody in chat will attempt to answer it for you.
Press for Dr. Stern. You've referred to this as auspicious beginning to the new year. Could you sort of elaborate on how you see this fitting into the exploration history of the world, most significantly 50 years after astronauts, flew to the moon and almost ready to, come up on the Apollo 11 anniversary? How it all fits together in your mind?
Sure. Thank you for the question. One of the things that distinguishes human beings from all of the other species on Earth is that we are so inquisitive and that we are naturally explorers. And I think space exploration really typifies that attribute of human beings. It's amazing to think that we as a species are interested in the rest of the universe and that we actually go out and explore it. And I'm very proud of our time and all the countries on Earth that are becoming involved in this historic enterprise. 50 years ago, the first humans walked on another world, the moon, as a result of NASA. And NASA was actually the first space agency to reach every planet in the solar system, from the closest planets, Venus and Mars, to the farthest, Pluto. And now we're out exploring even farther. And we put all the data in an archive where anybody in the world can see it. We don't keep it to ourselves, we share it. And I think that the kinds of things that NASA's doing are the envy of the world. And they go down in history, and they really set the United States apart as a leader. And I'm very grateful for all that.
Hi, Bill Harwood, CBS for Alan. What can you learn, some specifics about what can you learn about studying a cold classical KBO that you can't reverse engineer from looking at an asteroid or a comet closer into the sun? In other words, what is it that's frozen in time that's going to tell you so much about formation of the solar system?
Yeah, I'll take a cut at that, and I think maybe John Spencer might also add a little bit. But there are really two attributes of Ultima Thule that make it so scientifically valuable for us. First, because it's so far from the sun, and the sunlight is so weak out there, temperatures are down near absolute zero. And as a result of that, chemical reactions are essentially frozen. So the object is in such a deep freeze that it's perfectly preserved from its original formation. And when you combine that deep freeze with the fact that Ultima is a small body, only tens of kilometers across, and can't have a strong geologic engine, like Pluto, for example, which is also cold, but which you can see the activity on its surface and in its atmosphere, Ultima doesn't have the ability to evolve that way. So everything that we're going to learn about Ultima, from its composition to its geology to how it was originally assembled, whether it has satellites and atmosphere or those kinds of things, are going to teach us about the original formation conditions of objects in the solar system that all the other things that we've gone out and orbited, flown by, landed on can't tell us, because they're either large and they evolve, or they're warm and they've evolved for that reason. Ultima is completely unique. John?
I'll just add a little bit that it's part of this structure, as you mentioned, called the cold classical Kuiper belt, which is a remarkable structure. We have small bodies scattered through the solar system. We have the asteroid belt where things have been really stirred up, particularly by Jupiter. They've crashed into each other, broken into smaller pieces. Everything is very mixed up and not in its pristine shape there. And we have comets, which, as Alan said, have been altered a lot by the sun's light. But out there we have this belt of objects that are in almost circular orbits, that are flat orbits, the same plane as the planets. They have to have just, nothing has happened to these things since they formed. It's the only small population in the solar system, the only population of anything that we know of in the solar system, where virtually nothing has happened in the last 4 billion years. And so it's a very special region that we're very excited to explore.
Next question here.
Hi, I'm Ken Chang, New York Times. I was just wondering how everyone's feeling now versus 3 years ago at Pluto. Are you more relaxed, confident because you've done it at Pluto, or is it still tense because of all the challenges that Alan was talking about?
Who wants to take a crack at that? I can tell you that we're very confident in the spacecraft, and we're very confident in the plan that we have for the exploration of Ultima. But I'd be kidding you if I didn't tell you that we're also on pins and needles to see how this turns out. We only get one shot at it. It's nothing like this has ever been done before. And with any enterprise like this, there comes risk. Fortunately, the rewards are worth the risk, but there is risk to the spacecraft and to the science that we're trying to do. And I think by tomorrow morning, we'll know how it all turned out, so stay tuned.
Hi, I'm Alan Boyle with GeekWire. Based on that first image, and perhaps you've had a chance, I don't know, to look at the fail-safe imagery, I realize it's too late to make any sort of change in the flyby maneuver, but is there anything that this image tells you about what you'll be looking at? Does this kind of definitively say that it's an elongated object rather than two or more smushed together objects? What does this tell you?
John?
Yes. I think it's a little early to say. We know it's not round. We can say that with confidence. But yes, this is not inconsistent with it being two smushed together objects like the artwork that we've been showing, which we just don't have the detail to see yet. It could well look like this right now, but we will know very soon.
Alan, hang on to your hat. I have to say, I said to the science team last night when this image first came in, I'd never seen so many people so excited about 2 pixels.
But we've had only 1 pixel for so long.
Okay, I think we have some questions over the phone, too, so let's take one of those.
If the questions will work.
We have a question from Keith Cowling, NASA Watch. You are unmuted.
I actually had 2 questions to ask, but after hearing the email from Thomas, I'm going to ask the second one for Dr. Stern. You're going to have a spacecraft that is filled with fuel and obviously working rather well. Even if you're going after another Kuiper Belt object, you're going to have a lot of capability left over. Has any, and this is a way out question, but has anybody given any planning thought to a recreation of the pale blue dot image, albeit with a far more capable spacecraft and a little more time to plan it?
Yeah, so what the question is asking is whether New Horizons can reproduce the solar system portrait that Voyager took almost 30 years ago. In fact, we think we have the capability to do that, but it comes with some significant risk to the cameras because the planets are so close to the sun in angular terms, as seen from New Horizons. Taking that image runs the risk of burning the cameras out and actually permanently losing the cameras. So we don't want to do that until we're finished with all the flybys that we can possibly get out of this mission, and we do have an ambition of looking for another target after Ultima. So any image like that, which we very much want to take, will be years in the future.
Okay, I think we have another phone call. So I think we have another question over the phone.
Yeah, we have a question from Alexandra Whitby from Nature.
It's a little awkward doing this, and the audio feedback is a little annoying. I almost feel like they should have recorded the questions and then played them.
Okay, we can wait for that one. If we have any more questions here in the audience, let's go back to the audience first, and then we'll wait to see if we have the phone straightened out.
Hi, Andrew. Thank you very much. Stays up close. First, congratulations and good luck, all of you. Based on that first image and what you said about the no geologic engine, can you talk a little bit more about what you might expect or speculate on the surface of craters versus it being smooth or being something completely different? What are you thinking to this day? Thanks.
Well, I don't make predictions. I've seen too many of those go down in flames, and anything that I said today will almost certainly be wrong tomorrow. But I can tell you what we're interested in, and I'll give you one particular example for myself. We want to understand how objects like Ultima were assembled. There are two basic theories for how the building blocks of planets were assembled. In one case, you put objects together piece by piece, and in the other theory, they're built by sort of a hailstorm of pebbles and boulders and other kinds of particles. And depending upon whether we see a heterogeneous object or a monolithic object, we might be able to find out which of those theories is correct. John?
Yeah, I maybe say a bit more about the issue of cratering. Most small objects in the solar system have a lot of craters because they're old, they're not having geological processes that are erasing those craters, so they just accumulate scars from other things running into them over the age of the solar system. But a paper just came out that looked very carefully at how often Kuiper Belt objects run into each other. And it's not very often. There are hundreds of thousands of them, but they're spread over an enormous region of space, and they're all kind of cruising along in the same speed, in the same direction, kind of like on a freeway. And like on a freeway, fortunately, collisions don't happen very often. And so we may not see many craters at all. That would be a really interesting result. And if it's true, we might learn about the surface before it got covered in craters that would have been erased on other objects. So that's just an example of how little we know right now, and the kind of ideas that are out there as to what we might find. And yeah, we'll know very soon.
Okay. Let's do another one in here, and then we'll see if the phone line is open.
I mean,
Stephen Young
totally
with Astronomy
applies.
Now. Alan kind of hinted that the science team was excited by these 2 pixels, but I'm wondering if you could, either you, Alan, or John, say whether the science team has moved in any different directions with their conversations, speculation, interpretation, since they've seen this image?
John?
There's a lot of chatter in the science team room, and we're doing everything we can with so little information. It's kind of crazy because we're just so excited by this. But we know anything we say is going to be wrong tomorrow. And so ask us tomorrow, and then we may put you off another day. But we'll have much better images in a couple of days and these will be irrelevant at that point. So we're having a lot of interesting conversations, but we'll probably be wrong about them. So we'll wait until we know more.
Well, I'll just add one thing, and that is, after 3.5 years of planning for this, it's becoming very real all of a sudden.
Okay. We can stay here for a couple more questions, too, if we have them.
Hi, I'm Stephen Clark from Spaceflight Now. I was wondering, in the last day, have you been able to sort out anything about the rotation rate of this object? I know you've been searching for that for weeks, and you haven't been able to find anything. Any news there?
Right. So
They have 2 pixels. How?
by taking repeated images over time, we can see how the brightness of Kuiper Belt objects vary. And we've been doing this for years now as we cross the Kuiper Belt and studying the rotation periods of a whole suite of different Kuiper Belt objects. The only one that hasn't yielded a clear light curve is Ultima. What's up with Ultima? We don't know. And here we are now just, 10 hours from a flyby, and we still don't have a reliable light curve. We will find out why that is in the next 24 hours.
Give us another one in here.
Thank you. Tarek Malik with Space.com, and I think this question is for Helene. You mentioned in your talk that it'll take something like 20-odd months to get all of the data from this encounter back. And I know there was a similar kind of a year-long or plus for Pluto. And I'm wondering kind of how that data is prioritized. Why does it take so long to kind of get so much data from what is essentially just a few hours of glimpsing before you shoot on by like a bullet? Thanks.
Sure, thanks for the question. So the data downlink, we're not just taking data coming down from the flyby, but we're also making observations of other distant Kuiper Belt objects along our trajectory, or that are not along our trajectory, that are from a distance. So we have to get that data down as well. And the prioritization for the data downlink comes from the science team led by Alan. You know, they let us know what's most significant, what they'd like to see first. And also we have housekeeping data that lets us know if, you know, ensures us that confirms that the spacecraft and its subsystems are healthy and flying safely.
You know, I'd like to add, I am in awe that we can even do this. The technology that's involved is incredible. The spacecraft has a 15-watt transmitter on it. 15 watts. It's a quarter of a light bulb. You know, not 15 kilowatts like a radio station, 15 watts, and we're receiving it from 4 billion miles away, these incredibly weak signals. And the fact that we can send data back at 1,000 bits per second, given those challenges, is unbelievable. And, you know, when you combine that with these advanced scientific instruments that take data like a fire hose and put them in the flash memory on board the two computers, where they're stored, we completely fill those memories to the extent that the engineers will let us, and then trickle it back at that 1,000 bits per second. And remember, we have to share the deep space network with all the other missions that NASA's flying across the solar system. So the combination of all those things together spells out 20 months.
Okay, so now we have a phone question.
Yeah, hi, this is Alex with Nature. Can you hear me?
We got it, Alex, yep.
Great, thanks. I wanted to ask John to talk just a little bit more about shape, this elongation that you're seeing. How is that consistent with the results you were seeing from the occultation studies earlier this year? And what, if anything, does it say about if this is a multiple object kind of squished together, whether you might have 2 or 3 objects smushed together?
Well, yeah, we've been having fun playing games, taking this fuzzy blob that we're seeing in these images and comparing it, sort of superimposing it on this intriguing shadow outline that we got from the occultations last year. And it fits pretty well. There's a lot of leeway in that occultation shadow because we only have a few points on it. And there's also a lot of leeway in this fuzzy blob, obviously, because it's so little information. And the hints that we had of 2 bodies in the occultation, I think it's safe to say we still are consistent with that. We'll just have to wait just a few more hours to confirm that. But I'll actually point out one intriguing thing, and I need to borrow Fred's pen for this. So as Alan mentioned, we haven't seen a light curve. And if it's elongated, as it appears to be, it wouldn't be as elongated as this pen, but if it's spinning like this, sometimes you'd be seeing it broadside on, and sometimes you'd be seeing it end on, and you should see a lot of variation in brightness, and we just are not seeing that. So our current best theory is that it's actually spinning like this. And so though it's elongated and it's spinning, we're always seeing the same side. And so that's our current best theory, and again, that might be proved wrong tomorrow.
Okay, we got one more question here in the audience.
Kelly BD Sky and Telescope, hi. So given that your hope is that this is the most pristine possible surface, which of the experiments offer you the best chance to actually determine the composition of what you're seeing, especially if it turns out to be dark and red? Do you have some hope of, you know, gases being liberated, whatever, Pepsi, I don't know.
John, you want to take it? Or you want to take it?
Okay. I'm really interested in the color pictures that we're going to get because the Kuiper Belt is really intriguing in its colors. We have a variety of objects that are very bright, like Pluto. We have smaller objects that are kind of grayish colored, and we have other objects that are red or brownish in color. And we don't understand at all why there's this variation. And the cold classicals, this very flat circular belt of objects that we're that Ultima is part of, all seem to be red. Other parts of the Kuiper Belt have gray objects and red objects, and all these cold classicals are red. And that's really intriguing. It's a really important clue as to what's happening out there. And so by looking at the one object close up and seeing how maybe color varies across its surface, maybe it's brown, but it has gray craters, or who knows what. We might get some clues to what this big mystery is about the colors from that. But again, it's all speculation at this point. And it could be that the biggest clue is going to come from the infrared spectra that give us the surface composition. It could be that the best clues are going to come from the close-up images from our telephoto camera that will show us the craters, and the morphology tell us something about the history of its surface. Well, we just don't know yet, and that's what makes this so fun.
Because we had a little hiccup with the phones, I'm going to go one more time because I understand we have another call in the queue. So one more question from the phones.
Let's see if this works this time.
Okay, this is Keith from NASA Watch. Go ahead.
Yeah, Keith Kelly, NASA Watch once again. And here's my other question. This is a bit like, with the speeds that you're talking about here, this is sort of like Star Wars TIE fighters flying over the Death Star. And I was just wondering, given that it's the proverbial bullet going after a bullet, is there any interest, or has there been any participation on the part of the Department of Defense? I know APO has some contracts with DoD, and there are precedents like the Clementine mission, which did seek to track things, and oh, by the way, they used the moon to practice with. So again, the question is there any DoD involvement with this? If there hasn't been, will there be?
Let me give you a very precise answer, no.
All right, well, thank you for those questions there. I'll give you guys the opportunity. Any concluding thoughts from the panel?
Great job.
All right, we're good.
The last question was essentially, is there any DoD involvement? And the answer was no.
All right, so thank you for joining us. I will advise you, like our spacecraft, our schedule moves quickly. So keep following us online at nasa.gov and at pluto.jhuapl.edu. Follow us on social media with the hashtags Ultima Thule, Ultima Flyby, Ask NASA, and Ask New Horizons. We have several other opportunities and events coming up. This evening we are going to have a Ask the New Horizons team online. Plenty of activities tonight of speaking and team members giving overviews and background on the mission itself. And then, wait, just after midnight, we'll have the debut of a song, New Horizons, from Brian May, contributing scientist, New Horizons science team member, astrophysicist, and oh yeah, guitarist for the band Queen. And then at 12:33 a.m., we'll mark the moment where New Horizons will be flying by Ultima Thule 4 billion miles from home. So thank you for joining us. Keep flying with us and keep exploring with New Horizons.
All right, I'm going to turn their outro music down, as in off. So yeah, of course it's down for you guys, but not down for me. So I'm going to mute it there because it's very distracting. It's very nice music, but very distracting. So yeah, let me transition back over here. So yeah, that was cool. I had thought that there was something on at 4 as well, or at 3. It is saying, yeah, it's saying at 3 p.m. that there's a Q&A Ask the New Horizons team. So we are going to take a brief break. I'm going to get up and stretch and pet puppies because they are really struggling today because they just want to bark at the mail carrier. So yeah, stay tuned. I'm going to put up the Hold Please video if it'll load. And we'll be back in a bit. Hooray! Oh man. Oh man, this is awkward. So yeah, while I'm fixing this, please ask me any questions you have. Yeah, see, I can't even see the video, which is the problem. It's just not loading. Yeah, mistakes were made. Mistakes were totally made. Hey! Somebody donated. So let me flip over to cancel, cancel, cancel! Bits! Bits for the dogs! Bits for the dogs! More bits for the dogs! Thanks for your donation! So, I know how to fix this. I know how to fix this. There's a way to fix this. I'm just gonna put the dog cam up. And this is how we're gonna roll. Yup. There we go. There's the dog cam in all its glory. And... I should really get all of my different scene settings back to where they should be. But yeah, thanks for the donation. I am literally setting things up. He really is better than a Roomba. Alright, there's no good place for this, so we're just gonna dump it there. Okay, so yeah, I'm gonna let you guys watch the dogs eat all the Cheerios, and I'm gonna get up and stretch. I will neither confirm nor deny that I have a donut smashed over the lens to keep them looking at it. But I can confirm I have food and I am behind the camera. So, let me find a spot for this. I picked up more snacks. Alright, now. They are cute, aren't they? Come on. Over here more. Over here more. A little too close. A little too close. Alright. That is actually Fluffy's nickname, is the cuteness. Aw. And now there's Tinkerbell just off frame because the camera's taller than she is, and now they're just gonna beg. Alright, so while they're begging, how about I find out what's going on with the other thing? And it's something about the Apollo 1 fire on the NASA channel. So, let me refresh all the pages. It still says 3 p.m. So, sorry about all the noise with moving my microphone. Okay. So let's flip this over so you guys can at least see the video that I see. There we go. So yeah, no, everything is still set for, ugh, now it's just weird and in the frame and in my way. Alright, so, okay. They are talking about a moon landing and how risky it was, essentially. If anybody has questions about Ultima Thule, etc., or Ultima Thule, as they're now pronouncing it, apparently, because I've been pronouncing it all wrong for forever, please at me, and we're gonna watch the Q&A, which is supposed to be happening right now. Hey! Listen to every episode of Astronomy Cast, and this comes out to, about 5 cents an episode. Well, thank you. Thank you for the donation. I couldn't read all the text on my screen, but there, my dogs will be very, very happy. So yes, thank you, human. Thank you. We really, really appreciate it, and I will totally take 5 cents an episode. And it makes me very happy to see the donation bar inch even closer to full, because we totally realize that we're not going to hit our goal, but every little bit means we can keep working a little bit longer. And that's pretty cool. It's pretty cool to know that, hey, we have 3 months of work, very, very part-time work, but work. And that hopefully is enough to keep us, bridged until we get more funding. So, yeah, that video of the moon flying by so closely, yeah. Yeah. KSP flashbacks. I am still a little afraid of playing KSP. Oh, that's such a beautiful image. All these images are beautiful. And they're all data. All of this is data. Data can be so pretty. Data is so, so pretty. Hey, I think it's happening. Now they're saying 3:15. So, there's a terrible part of me that's like, let's play a game for 10 minutes, but that's not nearly long enough. And I don't trust my please hold video for 10 minutes. So, oh, we'll begin momentarily. Well, I'm glad I didn't swap anything over. I'm sure glad I didn't swap anything over. So, as an aside, does anybody know of any good astronomy-themed beers? I guess there's a brewery in Seattle, I think, that has a bunch of astronomy-themed beers. And I'm looking forward to trying it. Blue Moon. I don't think that's on my list. I'm on Untapped, by the way. And I will have to see if Blue Moon. Ground Control, but haven't been able to get it in about a year. Who brews Ground Control? Alright, I should also point out that I don't do IPAs. Is Blue Moon an IPA? Anything, I am apparently in that percentage of people that hops just tastes gross. An impossible to spell company that starts with an N. Well, we have Google and we have time. So let me go to Untapped and search for Ground Control, because Untapped will have the answer. I'll pull up chat so I can see it. Wheat beer? Okay, I can do a wheat beer. Now, I had a barley wine last night, and I didn't realize that they used hops. And I was like, what is this? Oh, I see it. Okay, Ground Control is from Ninkasi Brewing Company. I'm gonna link the Untapped page. Yeah, I don't do hops. I like stouts, I like porters. I don't really do hops a lot. And there's a strain of hops called Galaxy hops. So there's a lot of IPAs that are like space themed simply because of the strain of hops called Galaxy hops. And I'm like, oh my god, no. And I actually have a list on Untapped of beers to try. So add to list, space theme to try. Ground Control's on there. Let's look up Blue Moon. I don't do really bitter, and I guess some people hops taste like soap, and I'm not entirely convinced that I am not one of those people. Oh, Blue Moon is an entire brewing company. Oh my goodness. I wouldn't even know what IPA is good. Uranus. Oh, Sawdust. Sawdust doing long dark voyage to Uranus. Urinal and I can't even, part of me is like, what? Long dark voyage to Uranus. I am totally adding that. Long, dark. There it is. Sawdust City Brewing Company. Add that to my list. Drop Air Antics says, Hops Tornado or Torpedo from Sierra Nevada is one of my faves, but it's not for anyone. I will take your word for it. Alright, so pull up Blue Moon again. Blue Moon's an entire brewery. So what specific beer from Blue Moon, guys? I'm just kind of scrolling through their things. I've apparently tried the mango wheat. Yeah, I'm being told I tried the mango wheat and I didn't like it. Yeah, I gave it a 3. Ooh, vanilla wheat. I probably won't like that either. Cinnamon horchata? See, that sounds like something I'd try. So, let me see if I can pull up my list. Let's just do a search for ground control to see if there's any other. Oh, we have a really cool we have a really cool beer store here that could probably get me whatever I asked them for. They carry a lot of weird stuff. Disillusion says, you rated your first Jaeger bomb a 1, you rated your 12th Jaeger bomb a 10. Oh my. Goonbag Roulette from Drop Bear Antics says, attach said wine bag to a spinning clothesline. Get everyone at a party to stand around its edge. Oh dear. Spin the clothesline. Whoever it stops at, they got a drink from the wine bag. This, in Australia, is called the Goonbag Roulette. Oh no. Oh no. Favorite human, what's your take on that one?
I'm being climbed over by the dash.
Yeah, I know you're being climbed over by the Dachshund because the dogs aren't on Hey! Thanks for the sub. You're gonna lose the Dachshund in a second. Dachshund tried to escape.
Well, she almost fell off the couch.
She almost fell off the couch. Oh, so now they flip back to 3:15 p.m. Okay, that's fine. We can continue to talk about, you know, beers. An astronomy-themed beer.
Blue Moon's a fairly regular brewery, like Yingling and all the rest.
Yeah, Blue Moon is a pretty regular brewery. YYZ says wine bags give me total bogan flashbacks. I don't even want to know. Disillusioned says, I'm starting to think that NASA controls time. Yes, yes, today they control the time. They control all of the time. I am not amused by any of this. I'm just gonna bring it in and I'm not gonna complain because this is pretty freaking awesome. I'm just like, you know, people have lives and want to do cool things other than work, right? Oh, I hear noise. That wasn't. All right. I heard noise about the program is about to begin. You guys are still muted. All right. Does NASA control the horizontal? Do they control the vertical? I don't even know what that means, Drop Bear. I don't even know what that means. Oh, really? Just as I turn the... It is the Twilight Zone with the shutdown. Yeah. Yeah. Maybe I screwed up the reference to Twilight Zone. I don't know enough about the Twilight Zone. I mean, I know the theme song, which you may or may not be able to hear Favorite Human sing. Or was it the Outer Limits? I don't know. That was the Outer Limits, not the Twilight Zone. Okay, there we go. I'm glad we settled that. I'm glad that was settled. I mean, Twilight Zone, Outer Limits, shutdown, plus cool things happening equals, you know. Yeah. Ooh, there's a ground control. Oh, here we go. Here's the music.
Welcome back. After offering the media a chance to ask questions of the New Horizons team, now it's your turn. For the past week, we've been asking social media followers to post questions on our Twitter and Facebook pages. We also asked you to write your questions for the team before you entered the auditorium. We'll select questions from both groups and pose them to the team members, Dr. Alex Parker and Dr. Kelsey Singer, both co-investigators from Southwest Research Institute, and Gabe Rogers, the New Horizons Deputy Mission Systems Engineer from the Applied Physics Lab. And helping us moderate the discussion is APL Social Media Manager, Jessica Tozer. Jessica, over to you.
Hey, everybody. So you have asked your questions. Now we're going to answer some of them. One of the biggest questions we've been asked on social media in the last few days is why Ultima Thule? Why was this object chosen, and how was it chosen?
I can start with that one. We found 2014 ME69 in a search done by the Hubble Space Telescope in the year 2014. That's where that designation comes from. That search was a culmination of many years of effort. We started with ground-based observatories and moved to space-based observatories only when it was demonstrated to be absolutely necessary because the dense star fields in the direction that the spacecraft is traveling made it very difficult to find moving objects in the foreground, faint moving objects like 2014 ME69. We had conducted, over the course of the survey, we had made, we discovered about 50 other Kuiper Belt objects in addition to 2014 ME69. And before we conducted our Hubble survey, none of those had been actually targetable by the spacecraft. But they were close enough to the spacecraft that we can make long-range observations of them. Once we got the Hubble data, we found another 5 objects that were much closer to the trajectory. There were a few of them that were close enough that we could probably reach them with the spacecraft's remaining fuel supply. But after balancing all the benefits and risks and costs in terms of fuel and resources on the spacecraft, 2014 ME69 provided the best science return while minimizing the amount of resources that the spacecraft need to reach it.
That is great. And it's speaking of this object and its interest, a lot of social media questions have been sort of like, you know, what is this and what do we know about it? And so we got a question about the shape and orbit period of Ultima Thule. Do we know anything about that?
At this point, the information that we have on the shape mostly comes from observations we made here on Earth, the occultation observations that you've heard a bit about earlier, and you'll hear more later today when Mark Bowie speaks, give us a rough outline of its cross-section in one moment of time. And so from that cross-section, we have this idea that it is probably not a very simple shape, that it's at least elongated, maybe bilobate, possibly a close contact binary. We'll definitely know soon as the data from New Horizons improves and absolutely exceeds the resolution of the data that we got from the occultation. Its orbit is 298 years long. It takes 298 years for it to circle the sun one time. So it's much further out from the Earth. The sun's gravity is much weaker there, so it takes much longer for it to orbit the sun. That orbit is very, very circular compared to the orbits of other small bodies, and it's very low inclination, meaning it's close to the orbital plane of the planets. So it's in this very special region of the solar system that we've been talking about, the called classical Kuiper Belt, this very thin disk, very circular disk of material at the edge of the solar system. And that's about what we know about its orbit and shape at this point.
All right, let's move on to a couple of questions about the spacecraft in particular. One question that we got, especially from some school-age kids from Kansas, is how fast is the spacecraft now traveling?
So the spacecraft is now traveling about 14.4 kilometers per second relative to Ultima Thule. Basically, it's moving so fast that we're only at closest approach for, about plus or minus 1 hour on either side of it. And it's moving fast enough that ultimately it's going to go out of the solar system and continue on.
Oh,
I was going to say too,
something that I learned recently is that's about 30,000 miles per hour. So hopefully no one's ever driven that quickly down the highway, but it's a very speedy spacecraft.
I think you'd have to be. And so now that we're talking about some deep space stuff, I want to transition to a question that's what lies beyond the Kuiper Belt? We only really know the Kuiper Belt existed a little while ago, so what's beyond that?
Beyond the Kuiper Belt are a number of other structures in the outer solar system. This idea of the Kuiper Belt is really typically applied to just a few structures in the outer solar system, the cold classicals that we're flying through, this sort of scattered disk of material that interacts with Neptune continuously, things between sort of Neptune's orbit and a few times further out than that. But if you get beyond that, you get into other more distant regions, often referred to as the Oort cloud. And sometimes the Oort cloud is broken down into different subregions, like the inner and outer Oort cloud. The Oort cloud is the sort of source population for most of the really long period comets, the comets that we've only ever seen one time as they sweep through the solar system and go out and disappear into the darkness. It's thought to be more of a spherical swarm of material that was ejected very early on from closer to the sun by the migration of the giant planets after the giant planet formed. They didn't form exactly where they are now. They moved around a bunch before they settled into their final architecture. That motion kicked things up, stirred things around, and pitched a bunch of stuff out into space. Once things get out far enough, the rest of the galaxy starts to matter. It starts to reach in with its tenuous gravity and grab hold of things and lift them even higher very, very slowly. And so you isolate them in this very distant swarm of material. Right now, we have no plans to go and explore this population because it's so far away, hundreds of times, if not thousands of times further away than ME69 is. And so if we were to take a mission like New Horizons and try to go to one of these objects, it would take thousands of years, if not tens of thousands of years. So for now, we have to try to explore it remotely using our observatories, telescopes, and using techniques like occultations to probe it. But perhaps in the future, if we can engineer much faster spacecraft, we could push on further and go out and explore the Oort cloud.
Space is really big. So, this question was the most asked question on social media, so I think we should definitely get to it, and that is, how are you able to communicate with a spacecraft that's 4 billion miles away?
So basically on board the spacecraft, we have a high gain antenna, and we are able to transmit to the deep space networks, which have 70-meter antennas. And there's 3 different stations scattered around the United States, so we could always communicate with one of those stations if we needed to. It takes about 30 watts of power on board the spacecraft to talk about 4 billion miles back to the Earth.
And so basically, and then the other question was the downlink. How long does it take to receive signals, photos, things like that? You know, so people are saying it could take years, but
yeah,
it doesn't.
right now it takes light about a little over 6 hours to transmit from the spacecraft to the Earth. And even with all of that distance, we're able to get about 1,000 bits per second. So that's why it takes about 16 hours for us to downlink the images from a single observation pass in order to see it.
It's like using a modem in the 90s.
Yes, it is.
Yeah.
Except there's no dial.
Kelsey, this is a question I would hoping you would answer, and that is, what are you hoping to find out during this flyby? What are some things that you're really looking for?
Great question. So, I mean, we're going someplace we've never been before. I'm expecting to be surprised, but since I do mostly geology and geophysics, a lot of the things I'm looking for are what kind of features are on the surface. Do we have cracks? Do we have faults? Do we have craters? Do we have features we've never seen anywhere else in the solar system? I would not be surprised if we find some. We're also looking to see, does Ultima Thule look like a comet? Does Ultima Thule look like any of the moons around some of the giant planets? And we're going to be comparing what we find to learn more about all of these objects as a whole.
Which is an incredible thing, since we've never had the opportunity to really explore a Kuiper Belt object ever before.
For sure.
What is so significant about the Kuiper Belt in regards to science? Like, why is that important for us to better understand?
I can give a start to that and see what my colleagues here have to say. But we believe that Ultima Thule, as has been mentioned, is what we call a cold classical Kuiper Belt object. And the cold does not refer to its temperature, although it is very cold out there. It refers to the orbit that Alex was talking about. And we think it's been sitting in this orbit, in this distant place in the outer solar system for most of its life. And so it's a unique piece of the early solar system that hasn't had, we think, a lot of...
Thank you, Human, for your donation. Yeah! Puck is very happy with you, too.
For example, on Earth, we have lots of geology going on, and that erases a lot of the signatures from earlier in time. So we're really hoping that that piece of the Kuiper Belt that we're going to right now will help us learn about how the solar system formed.
Yeah, I think it's really important to recognize one of the, there's words like primitive and pristine and ancient that are used a lot to describe things like the cold classical Kuiper Belt objects like 2014 MU69. And the thing is that most of the things that we go and visit in space can be described that way in one way or another. And one of the things that really makes the way that we're talking about the primordial nature of MU69 is that it can be linked directly back to where it formed. Almost all the other populations that you see, the asteroids and small bodies, and even the planets themselves, they didn't necessarily form where they live today. So if you want to take what you learn about an object and try to back out what the environment in the solar system was like in a particular location, try to understand the processes that were at play, that were building the planets, you have to bring in all this other information to try to work out where that object actually grew up. And a lot of that is model dependent. It requires you to make inferences about what everything else was doing, and it's a big puzzle. And one of the nice things about the cold classical Kuiper Belt is that, as best we can tell, it formed exactly where it is today. And so if you want to link properties of somewhere in the disk to the primordial disk that formed the planets to a population of objects that we see today, that is most easily, clearly done by going to the cold classical Kuiper Belt.
So this kind of leads to a different, goes into another question, and that is about the distance. So we're going to get so much closer to this object than we got to Pluto in 2015. Why was the distance chosen for this object?
Flyby distance.
So we were trying a few years ago to decide what the optimal distance was going to be that the spacecraft could easily do from basically a hardware standpoint, but also give us the best and optimal science. Obviously, we could get a lot closer, but if you do that, you get higher resolution images, but only for a very short period of time. And then the phase angle, basically the angle between the sun and the spacecraft wasn't as good, so you couldn't see a lot of the wonderful craters and stuff. If you get further away, you're actually able to take more images. You're able to scan over the uncertainty ellipsoid a lot more. However, the resolution is not the same. Then there was the question of, do you fly ahead of the spacecraft, or ahead of the body? Do you fly behind the body to try and get an occultation like we did at Pluto? Do you fly north? Do you fly south? So the scientists debated, and they ultimately chose the aim point that basically optimized the scientists for all the different instruments.
And here's another spacecraft question, and that is, how does New Horizons continue to sustain itself even though it's so far away from the sun and hurling through space?
So we are carrying essentially right now about 190 watts of power provided by plutonium in an RTG. And that also provides heat for the spacecraft. So the spacecraft is essentially like a thermos bottle, and it's being heated by the decay of the plutonium. That decay basically creates all of the power that we need to do to fly the spacecraft, to communicate back with the Earth, to run all the onboard instruments, and basically to take the images as we fly by. This power degrades over time. So every year we get a few less watts of power, so we have to get creative in how to maintain the spacecraft as we get further and further away from the Earth.
Is there a distance where you would no longer be able to communicate with New Horizons?
Yes, there actually would be a distance. Because we've only got about a 30-watt transmitter through the high-gain antenna, the further away we get, the lower the data rates get. And at some point, we would get far enough away that we wouldn't be able to get data rates that would reasonably be able to play back images. But we expect by the time that that happens, the plutonium will have actually decayed to a point that the spacecraft would start to be too cold in order to keep itself warm. The hydrazine and the fuel tanks would freeze. And that's probably what is going to be the end of life for the spacecraft, not the communications distance.
And that's going to be mid-2030s?
Mid-2030s.
It'll be a A cold death, but at least we'll hear about it.
So optimistic.
Yeah.
It's going into cold storage.
Yeah.
Yeah.
So what do you think is next for New Horizons? Just going to keep on going then, yeah?
Well, we have a couple observations already planned that will be executed on the spacecraft, looking at more of these distant Kuiper Belt objects that we discovered in our earlier surveys. These will be more of these long-range observations that we've been doing, trying to look at their surfaces from a unique vantage point, actually looking back at them toward the sun, not as close as would be required to look at the Earth per se, but by looking back at them like that, we can see light that scatters off of diffuse structures like, say, rings. So we have some objects after 2014 ME69 that we're already planning. We've conducted some observations using the CTIO observatory in Chile and their dark energy camera, which is this wonderful new instrument that covers a lot of sky, to go and actually look for some new targets that are even further from the sun than 2014 ME69, things that we could target at long range from the spacecraft between 2019 and 2025, for example. The reason why we have to do these searches now and we don't put them off is because the earlier we can find these things, the earlier we can define the requirements for them and make our plans. The earlier we make those plans, the fewer resources they require on the spacecraft. So we really have to front load everything like that.
I was going to say, also, I mean, we're obviously also going to try and find another target to do a close flyby of. It's a pretty low chance, but it's worth a look, and we're going to use the instruments on board the spacecraft as well to try and do that.
We've been very careful about managing the onboard resources, the consumables like propellant and thruster cycles, all through this extended mission. So we have been able to keep a little bit of extra propellant in the tank in case we do find another object down the road. And so we're always keeping that sort of monitored closely.
All right, we're going to take a couple questions from the audience here today. One of them is, what matter composition do you expect to find in Ultima Thule?
Oh, yeah, that's a great question. We don't have a lot of constraints on the composition already. So we'll be learning a lot with the instruments on the spacecraft. And we'll be able to look at the overall color of the object, and that can tell us about composition. And we also specifically have an instrument that measures in different wavelengths in order to get a signature of the composition. So we could find some different types of ices. We might find water ice. We might find more what we call exotic ices that only form in very cold places. We don't have these kinds of ices on Earth. Things like we found on Pluto, methane, ammonia maybe. And then there's also something that's making it dark. And we don't know exactly what that material is. So we'll be checking that out.
Yeah, this is one of the things to recognize about these objects is that they're very far from the sun, so they're very faint when observed from here, and they have these dark surfaces. They're look like asphalt in terms of how dark they are, what we do know about their compositions a priori going into this come from remote observations done from the Earth. And so there's only a limited number of things we can tell from this kind of distance and with these kinds of faint targets. And 2014 ME69 is the faintest of them. There is no fainter object that we've tracked and studied to this detail anywhere. And so it's really been one of the most challenging ones to describe ahead of time. But what we know from studying objects that have moons, which can tell us about the mass of the system and the size of the objects in the system, is that they're probably mostly made of water ice. They have a density, their bulk density is comparable to that of frozen water, and that there's other minerals mixed in. There's been some indication that there are silicate minerals present in Kuiper Belt objects. And larger objects can hold on to more things because things that tend to evaporate, these exotic ices, which we'll hear more about later today, they're easier to be held on to by larger objects. So things like Pluto could have all sorts of exotic ices on it, but something as small as 2014 ME69, it will be a lot more surprising to see some of the more really, really volatile compounds. So if we see them, we'll know that there's something kind of unusual going on.
And in the vein of exploring strange new worlds and seeking out new information, what is the significance of the circular orbit?
Well, the significance of the circular orbit, so the Kuiper Belt has many, many objects in it, billions of objects. And if you were to pick any one of them, they're going to have, on average, a more circular orbit than most other populations of small objects in the solar system. The fact that 2014 MU69s is really quite circular is probably just a reflection of the roll of the dice. It belongs to this population. Some of them are really circular, some of them are not. We don't think that indicates anything particularly special about 2014 MU69 with reference to the rest of these objects that are members of its extended family. We don't think that necessarily means that it's even more pristine than something else in the cold classicals, but it does help us confirm, it really helps support the idea that it really belongs to this family of special objects.
It's good that we're exploring a special object. We wouldn't want a non-special object
No.
for something like this. How are you able to take pictures in space, especially since space can be kind of, you know, dark?
There's a lot more light in space than one would think. And the cameras that were designed for New Horizons were designed to work deep in space, far away from the sun. We actually took a lot of images on our flyby of Jupiter back in 2007. However, we had to be very, very careful there because all the reflected light from the sun at Jupiter was way too bright, and it actually saturated out a lot of the images. So now that we are out in the Kuiper Belt, we're actually in the region of space that New Horizons was designed for. We've actually developed a series of long exposure images. So in order to see MU69 early after we spun down in August, we developed a way for the spacecraft to take these 30-second exposures and really try and get down to get every little photon inside the camera. And you've seen the results.
I was going to say, we had an experiment, so to speak, at Pluto, where we tried to have people guess what the light levels, what they thought the light levels would be at Pluto, because Pluto is also very far. But it turns out it may not be as dark as you would think. It's actually about twilight time, dawn or dusk, and that's what it would be at noon on Pluto. But MU69 is much farther, Ultima Thule is much farther, and so it will be darker there. But as Gabe explained, our instruments are designed for this.
Yeah. It really helps to have big eyes. You know, if you go into the deep ocean, you know, the giant squid have eyes the size of a dinner plate, and New Horizons' biggest eye is about that same size. It's all about collecting as much light as possible.
Do you know if Ultima Thule has a magnetic field or magnetic poles?
I can answer that. There's still a lot of unknowns about how planets generate magnetic fields, but we do have some information that we think is necessary in order to have a magnetic field. And that usually requires you to have a melted or partially melted interior that has something that can conduct electricity. And in the case of most of the planets, it's iron. And it's relatively unlikely that an object as small as Ultima Thule has a melted interior or ever had one. It's probably mostly made of rocky and icy materials. So it's pretty unlikely that Ultima itself ever had a magnetic field. There's a very small possibility that it's a small fragment of a much bigger object. And in that case, maybe that bigger object had a magnetic field, but all in all, pretty unlikely.
So this object's pretty far from us, and sometimes a unit of measurement is an AU. And so one of the questions is, what is an AU, and why is it used to measure distance in space?
It is not the internet parlance of absolute unit. It is the it is the astronomical unit. It is the average distance from the Earth to the Sun, and it is used as a useful yardstick. So if we say something is at 44 AU, it means it is 44 times further from the Sun than the Earth is on average. And one of the reasons why this is a useful tool for us is that it makes certain calculations kind of easy. If you want to look at how much something moves in the distance from the Earth moving back and forth, kind of like holding your finger up and closing one eye, then closing the other, and seeing things in the distance move back and forth from parallax, using distances that are in multiples of the baseline that we have, the Earth's diameter, the Earth's orbit's diameter, is really useful. So it helps make the math simpler and easier to do in your head, pretty much. So it's been around for a very long time. It's a great unit for scaling how bright things are, how long it takes to get places, how big something looks in the distance, and that's why it's hung around as long as it has.
And Kelsey, you answered this a little bit, but let's expand on this. Would you consider Ultima Thule a comet, a dwarf planet, something in between?
Good question. Yeah, so the comets are former Kuiper Belt objects that have been kicked into the inner solar system. And so they're not unrelated, but they're not exactly the same thing. Some people may be familiar with Comet CG, which the Rosetta mission went by. And that's about 4 kilometers or so across, whereas Ultima Thule is closer to 30 kilometers. So you can see there's a pretty big difference in size as well for what we've explored up close in the inner solar system versus what we're going to now in the outer solar system. So there is a relationship, but they're not the same. And Ultima Thule is a little bit too small to be a dwarf planet. But it's going to be an interesting object nonetheless.
Why would you consider this such a historic moment for space science?
I mean, this is the furthest exploration that we've ever done from the Earth. I mean, when we launched, we didn't even know that this existed. And now we're going to be, in a few short hours flying by this. 30 years ago, we didn't even really know all of the details we knew about the Kuiper Belt. We've learned about the third zone within, these last few decades and stuff. And now we've got a mission that's been traveling out there for 13 years, and we're on the cusp of exploring something that nobody's ever seen before. And that, for me, that's really exciting.
I'm really excited too. Do you think Ultima Thule is emitting heat, or could it possibly?
Pretty much everything in the universe emits some amount of heat. It is warmer than its environment. It is warmer than the cosmic microwave background radiation, and so it is emitting heat. Or rather, it has heat, it is warm, and it is emitting infrared radiation that we perceive as warmth, intangible warmth. And so one of the things that we'll be doing to measure that is using the REX instrument, the thermscan measurement, which allows us to pick up that kind of thermal radiation from a warm object. And when I say warm, it's close to absolute zero, but not so close as to not emit anything.
All right, last question for all of you, but don't answer simultaneously. And that is, why are you personally excited about this?
I'll start off. I mean, I've been on this program since nearly the beginning, at least as long as it's been here at APL. And so I've seen the development of this from basically a concept on a piece of paper all the way through INT launch, the flyby of Jupiter, the flyby of Pluto, and now the flyby of Ultima Thule. So this has been a fascinating journey that I've been on for these past few years. I'm really excited to see what we find, because every time we find something new, it is fascinating. And so for me, that's why it's really exciting right now.
Go ahead.
Okay, yeah, I mean, it's hard to be going by a type of object that you've never seen before. So it's just great to be able to learn about this new place in the solar system along with everyone else.
For me, I've been studying the Kuiper Belt for the duration of my academic career this far, searching for objects in it, characterizing objects in it, but it's always been the kind of thing where I'm learning a little bit about a lot of objects, and there's never been this opportunity. So I have this sort of understanding and relationship with the Kuiper Belt as a whole, but there's never crystallized into a single object where I get to know a lot about one thing, and that's what we get to do with 2014 ME69.
All right, well, thank you guys all so much for being a part of this and answering questions from the audience today. If we did not get to your question today, that's okay. We are still going to try to answer questions on social media, on our Facebook and Twitter throughout the day from our experts who are far more knowledgeable than I am. And we're going to try and explore as many questions as we can as we seek all answers together. So thank you so much.
Thank you.
Super cool music. It is actually pretty super cool music. And that was the social media Q&A. Ta-da! Now we transition back to host. Okay, so that was pretty cool. a lot of good info. I think it was really nice to see not to see, but to hear why each of the panel members was super excited. Disillusion says, now for the rest of the 48-hour coverage. Oh dear. So yeah, speaking of coverage, we will start back up again at 8 p.m. Eastern time, so that's about 4 hours from now. And that coverage will essentially go to, oh my goodness, I need to get that please hold video going. That coverage will essentially, one way or another, with an hour break in there, go from 8 p.m. till about 1 a.m. At 8 p.m., they're going to have a panel discussion on the exploration of small worlds. And then after that, from 9 to 11, they're going to have Ultima Thule flyby countdown events and mission updates. And then at a little after midnight, they're going to have the global song release, which we may or may not stream that because I don't want us to get muted. And starting at 1:15 midnight Eastern time, we'll start with live coverage of Countdown to Closest Approach, which is at 33 minutes after midnight. So, yeah, there's a lot going on today. Let me pull everything up. Yeah, there's a lot going on today with this, and there will be coverage for the next few days, usually just like an hour or two. We have them marked as events on our Twitch page somewhere, so you can go ahead and set yourself reminders for those. But yeah, tune in later for more New Horizons goodness. You can go ahead, if you have any questions, even if you missed the live stream, if you have any questions, leave questions on the stream. Leave your questions now. Put your questions in Discord. And at some point tonight, I will get to them and somebody will answer them. And yeah, stuff and things. New Year's Eve, New Horizons. Woo! This is pretty cool. So I will see you all later. And oh dear, I realized I don't have credits ready. This is super awkward, and I do this every time. But yeah, join Discord if you're not already in Discord, because that's totally where all the action happens. Okay, I found all the things, and I see chat happening. But yeah, thanks for tuning in, and I'll see you guys later.